All right, and welcome. Today we're going to be discussing a 3D printed buildings and kind of talking about the structural analysis of this. And so my name is Nicholas Gillette, and let's go ahead and get started. So first, let's start with what is 3D printing. As a quick reference, what we're going to be looking at is 3D printing is typically a layer by layer process. You can see a 3D printer in the lab, and what it uses is a type of plastic that it lays down layer by layer, and it's able to build a model through said capacities. So when we upscale that, we can actually see construction 3D printing. And this construction 3D printing is something of what resembles in the background. It's a layer by layer process that is usually using a concrete type mixture and layering it down layer by layer in order to build something larger, such as a building. Although we have seen some examples of a 3D printed pedestrian bridge and its implications that are going out.
Hi, and welcome to Cool Gadgets and Stuff. A construction 3D printer is a machine that can build houses by depositing a material like concrete layer by layer. Construction 3D printing saves time, uses less material, and requires less manual labor. In today's video, we are going to take a look at several companies at the forefront and some notable projects from the last couple of years. Apis Core is developing a 3D printer that can print houses and even entire buildings. The company says building homes with the bot is more efficient and less expensive than relying on humans. A building of any size can be printed just by moving the printer around. The footage you're seeing is from a pilot project for a municipal building in Dubai. Apis Core can print the walls of a standard home in just 2 to 3 days, while traditional methods will take about a month to complete. Right now, it can only print walls. Roofs, floors, foundation, electrical systems, and plumbing are all done by traditional methods. It also makes it possible to reduce the used materials, tools, and waste during the construction process. Currently, it is only suited for low-rise buildings, but the plans are to develop it to enable printing of high-rise construction, as well as foundations, floors, and roofing. First generation of this machine is set to be available for purchase sometime in 2020. Italian 3D printing company Wasp has built a house to showcase the abilities of Crane Wasp, their modular 3D printer that can create homes in a variety of formats and sizes. Called Gaia, this 30 square meter or 320 square foot house has a 3D printed outer shell and internal timber beams holding a timber roof. The house was printed using a natural material mix made from soil taken from the surrounding site and waste materials from agricultural industries such as chopped straw and rice husks. The mixture is layered using a 3D printer suspended from a crane, creating walls with vertical cavities inside, which are filled with rice husks for insulation. The building's walls have been designed with complex geometrical features, with the aim of embedding natural ventilation and thermoacoustic systems that are difficult to replicate with traditional construction. The house is high energy performing and does not need heating or air conditioning, as it maintains a mild and comfortable temperature inside both in winter and summer. It took 10 days to create the outer shell, with a wall thickness of 40 centimeters or 15 inches, and a total material cost of about $1,000. Crane Wasp is easy to assemble and disassemble, and more than one can be set up in a modular way in order to print larger structures. This project offers an innovative solution and represents a significant achievement in the field of green building.
All right, now that we've looked at kind of what 3D printing for construction looks like, some of the obvious ones, benefits are going to be listed on the screen here. It saves time, saves man hours, able to extrude 24 hours a day. These are great things. One of the other side effects that I was reading one of the articles, it's also very quiet. You could put it next to a school without major distraction. And the materials can be totally environmentally friendly, whether it's recycled concrete or maybe we put ground up bits of recycled plastics in the concrete mixture. So all of this would be good for the planet and make an environmentalist stay. Some of the drawbacks that we have is that we cannot effectively produce ceilings, roofs, foundations, or even have access for utilities there. And it's currently only suitable for like low-rise buildings. It's not necessarily going to be a 2, 3, 4, or 5-story building yet, but it does look that we are headed that way for a while. Um, However, I do want to make sure that everyone understands that just because it is cheaper doesn't necessarily it equals better. Even though we can have better technology implemented in them, healthier living situations, whether we put more insulation in the walls, all of these things can be great, especially for West Texas. But that doesn't necessarily mean you're going to want to drop everything today for your pier beam or your foundation house and just go immediately over to this. We are still going to be working on those things in the future. One of the big drawbacks is the effect that it leaves. As a layer is extruded, the nozzle will push the bed down or push the layer that it is extruding down. And when it goos out, it produces something that a architect called the sausage effect, and it has stuck since. And you can clearly see they're just little striations. Through up here, you can see it kind of got messed up a little bit. And as these things, it's very difficult to remove and make it still have the same effect. But what it can be done is you can plaster over it, and it doesn't increase that much of the time. However, it does add extra labor and resources back into the structure. So that's one thing engineers are currently working on. Something else that we do want to see is the structural analysis of it. So where we will see the walls of the building, we will definitely see it is a concrete truss on its side. A lot of these firms have blatantly said this is exactly what they want to do. This is the way they want it. As it is a load bearing in compression, the concrete loves it, and so the prints are going to be just using the crisscross or this beautiful just like basic truss looking layout. Another thing that I'd like to point out is how difficult it would be to make a nozzle that is able to do this. This is a very special print that I saw. It was being solicited as a nozzle that can go in multi directions. And so you can actually see it's got angles here, and then it stops, and then in the middle here, after it meets itself, it actually goes across flat again. And that is one of the benefits of their specific printer, but that is not to be expected in most. Overall, we could expect to just see horizontal base, but that might be incorporated in future designs of other projects. So speaking of other projects, where is this being used now? Well, it's currently being used in Austin, Texas. In the top left, we can see it being used. This is the Icon printer right here. This is a large machine over on the side, and this is making low-income housing affordable. Also looking at sending a few overseas and creating some low-income housing for third-world countries. We can see that over here, this is the longest 3D printed concrete bridge in the world. It's currently in China, and look at the side, the details on the side. It's got this beautiful ripple effect. I think it's absolutely wonderful what they were able to do with the architecture of this, and it really shows that the whole capacity of everyone is on it, and it's just doing fine. Up here, we've already seen the WASP. This is the Italian firm that has been doing this one, and they are more concerned with the environmental effect, as we kind of heard from the video. This one right here, this is a really interesting. They are doing living spaces as well as office spaces. This is an office space, and they'll frame it out right here, put a door in, and then put a roof on this bad boy and make it all set and good to go. So with that, we can also talk about concrete as a form of art. And this is something that I found was absolutely fascinating. Right here, this is holding the roof of an elementary school. And they wanted to visualize or simulate what it would look like if a tree were holding it up. And so they were able to make this beautiful concrete print, and it is full of cement, so it is not hollow. And it is holding up as a structural member and so the weight of this roof is being translated to this as a column. And here's some other really cool and interesting columns that are being designed, and they just have them on display up here. This is the first pedestrian bridge that was put into use by a Danish team, and they, as you can see, this right here is actually the way it was printed. Let me go to the next page. This right is right here, and you can kind of see the edge of the bridge as you now can see. The deck will span right across here, and they'll put the asphalt on top of that. So here we were setting up a large print that was made off-site, and it was just shipped to here, and they're just essentially mortaring this together with a waterproof mortar, and then they will have a two-story concrete building that they are able to do that with. Down here, this is just going to be for a public park as it's being printed off, and you will be able to maintain your social distancing with this beautiful scaping that they're doing. Lastly, up here, this was a house that was made by a Russian company, and they claim to have been able to 24 hours, which is an incredible feat, installed windows and all. So if we are able to do this, this would make it exceptionally easy to translate that machine to somewhere that is very inhospitable, let's say Mars or the moon, and get things set up and moving in those locations. But with that being said, this is the future of concrete and concrete design. Thank you very much.